So today we're going to take a look at a different kind of reasoning. You might remember a couple days ago we talked about inductive reasoning. And it actually says right at the bottom of our page right here, not at the bottom, but in the middle right here it says, recall, inductive reasoning is reasoning that uses a number of specific examples to arrive at a conclusion. So, for example, when we were talking about our shapes, I don't remember the exact pattern of it, but when we were doing stuff like that, we were using a specific number of examples to arrive at a conclusion. We were saying things like, well, I know that the 8th example is going to look like da-da-da, whatever it looks like, and that's how I'm going to arrive at my conclusion. Today we're talking about a different type of reasoning, deductive reasoning. Reasoning that uses facts, properties, or definitions to reach logical conclusions from a given statement. So, for example, if I look at this first one, it says, in Miguel's town, the month of April has had the most rain for the past 5 years. He thinks that April will have the most rain this year. Now, what kind of reasoning is that? Is that inductive or is that deductive? It is inductive. Because remember, we said that when we're talking about inductive reasoning, we're talking about a specific number of examples that is helping us reach that conclusion. Miguel is looking at the past 5 years. That's kind of a giveaway right there. That we're looking at a specific number of years that he is noting that April's had the most rain, so he thinks it's going to be the same this year. But then let me look at the second one. Sandra learned that if it is cloudy at night, it will not be as cold in the morning than if there are no clouds. Sandra knows it will be cloudy tonight, so she believes it will not be cold tomorrow morning. Something that you should notice about this one is it's a little bit more general. It's not giving me any specific number of times or number of months or number of anything to make her conclusion. For that reason, I'm saying that this is deductive reasoning. She's just kind of making a conclusion based on some general information that she has learned. So let's move on down here and let's talk about some other stuff. We're going to talk a little bit more about validity. We've kind of talked about validity in terms of truth values and truth tables, but in terms of this lesson, we're saying an argument is valid if the premises and conclusion follow a logical form. This essentially means that the conclusion logically follows from the premise. So what does that mean? Let's take a look at there's a couple different laws in logic that that this kind of falls into. The first being law of detachment. So what law of detachment means is if I have a conditional statement that they are telling me is true, and P is true, my hypothesis is true, then I can conclude that Q, or my conclusion, is true. So for example, let's take a look at this one. It says that if a car is out of gas, then it will not start. Sarah's car is out of gas. So I'm going to assume that this is true. My whole P implies Q is true. That's my conditional statement. I am going to also assume, well, I'm not really going to assume this here. That this part is my hypothesis, and this part is my conclusion. So they are telling me that Sarah's car is out of gas. That's called, I'm going to call that a given state. A valid conclusion that I can make, valid meaning it logically follows from the premise that I was given. If Sarah's car is out of gas, something I can say is, Sarah's car will not start. That's a logical next thing to say. If they're telling me, I know that if a car is out of gas, it will not start. If Sarah's car is out of gas, I can, with confidence, say, okay, then Sarah's car isn't going to start. So let's take a look at the back page of that, and we'll look at a couple other examples. What it wants me to do here is it wants me to determine whether the conclusion that they gave is valid based on the given information, so using this law of detachment. Now this can be a little bit tricky. So they're saying, they're giving me, if a figure is a square, then it is a parallelogram. That's my if-then statement. If a figure is a square, that's my hypothesis, then it's a parallelogram. It is a parallelogram is my conclusion. So they're telling me, they're giving me my conclusion. They're saying the figure is a parallelogram, okay? But the conclusion that they have made is then, okay, if that is the case, if my conclusion is true, then the figure must be a square. If my conclusions are true, then it has to be a square. Now this should look a little bit funny to you, because they're taking you back to the hypothesis, which kind of naturally leads to the conclusion. We said that a valid argument starts here and goes this way and leads to my conclusion. This goes backwards. So it says, identify the hypothesis and the conclusion Q of the true conditional. This is my true conditional. This whole, if the figure is a square, then it's a parallelogram. And then analyze the conclusion. The figure is a square. That was my analysis. That doesn't really check out to me. It's kind of strange that they kind of went backwards like that. So my answer to this question is determine whether the conclusion is valid. The conclusion is not valid, or it's invalid. Think about this in terms of counterexamples again. They said the figure is a parallelogram, so the figure must be a square. Not necessarily. What if I say figure's a rectangle? It fits that same, it kind of fits in that same logical reasoning that they just used. It's a parallelogram, but I don't have anything there to officially tell me that it is a square. I have to start with that square part. So let's take a look at, why don't you guys try, you try this guy right here. If a polygon is a convex quadrilateral, and see what answer you can come up with. Remember, your answer is basically either going to be, yep, this checks out, this is a valid conclusion, or like what we did up here, the conclusion is not valid. So those are pretty much your two options. So pause the video and try and get that done. And once you're back, let's take a look at this final law that we've got. This one's a little bit easier, I think, than the law of detachment. Detachment kind of, you have to think a little bit more about. The law of syllogism says this. If P implies Q, remember, I can say if P then Q, or I can say P implies Q. And Q implies R. Again, each of those are just different little statements. If those are true, then I can say P implies R. I can say that's true as well. So if I have this, if you get a job, then you will earn money. If you earn money, then you will earn a job. Then you will buy a car. If you get a job as my P, I can say you will earn money as my Q. So this is my Q here, and then there's my R. So those are all my different statements. My valid conclusion that they gave me is if you get a job, then you will buy a car. So that kind of flows a little bit nicer than that law of detachment, because basically P goes to Q, Q goes to R, so now I can say, okay, P goes to R. So then let's take a look at this one. Actually, why don't you guys try, like I said, this one's a little bit, law of syllogism is a little easier, so why don't you see how you can do on that one. Okay, now after you've done that, let's take a look at the next one as well. This one is a little goofy. It says if your alarm clock goes off in the morning, then you will get out of bed. If you ride a bus, then you go to work. Now, This is another one, kind of like one we looked at before. You should be thinking, well, none of that really makes sense. If your alarm goes off in the morning, then you get out of bed. Okay, that makes sense. If you ride a bus, then you go to work. There's no connection between those two statements. You need something to kind of bridge them together. Maybe if you get out of bed, maybe you'll get on a bus and you'll go to work, but I don't know that for sure. Those two statements aren't really related at all. So my conclusion is, again, there is no valid conclusion. That's just kind of a jumbled mess of a bunch of stuff that I don't care about. So I can't make any conclusions from that. Okay. I'm gonna let you guys try these ones as well. These final two. You're basically, take a look again. If you have to flip back, take a look at what the law of detachment is and the law of syllogism, figure out what the difference is, and answer those two questions. What you're doing, I want you to come up with a conclusion based on the information that they give you. And then I want you to tell me what law you used. How were you able to make that conclusion? So we'll talk about all of the U-tries. There were a few in here. We'll talk about those next class. And we'll keep pushing through all this logic stuff.